everybody. In this video, we're going to talk about the number zero as well as the unary operation of absolute value. So the concept of zero is actually a pretty advanced mental construct. And in a lot of ancient numbering systems, they didn't even have a symbol for the amount of nothing, because it is sometimes a counterintuitive thing to have a object or a symbol represent the idea of having nothing, because nothing is nothing. So why would you use something to represent it? But there was one ancient number system that did use the concept of zero. So in the Mayan numbering system, it was composed mostly of dots and lines. So they would use lines to represent the number five, and then dot, like a combination of dots, to represent the numbers one through four. And then they'd use combinations of lines and dots to represent the bigger numbers. But the thing that was kind of interesting about their number system is that they would use a symbol like this to represent the number zero. And the reasoning behind that symbol is that it's an empty corn husk or an empty seed husk. I can't remember which one it was, but some kind of empty like shell. And so they used that picture of an empty shell to represent the idea of having nothing. And it's also kind of interesting to note that one of the things we use in modern times to measure the intelligence of animals is whether or not the animals can understand the concept of zero. So they've done different experiments and things, and it turns out that there's some animals who can understand the concept of having something that represents the idea of nothing. So some of the animals that can do this are monkeys and dolphins. They just recently found out that bees can do it as well. There's also other animals like I think crows and parrots, and I can't remember all of them, but some animals can make that mental connection between having an object or a picture or something represent the idea of having nothing. Versus other animals, they might be able to understand the idea of counting numbers, but they don't understand the concept of zero. So that's just some interesting trivia. But the way that it will relate to your teaching is just as a reminder that not all of your students, especially in the younger grades, will find it super intuitive to have an object or a symbol that represents the idea of nothing. And you'll see this in some of the case studies that you'll read in this course, where the students will talk about, is zero really a number or is it not a number? And on a related note, I want to talk about the unary operation of absolute value. So, the definition of absolute value is that the absolute value of any input into this operation, so we'll call it x, the absolute value of x is defined as the distance from 0 to x on the number line. So, the output of absolute value will be the distance from 0 to whatever number you input. So for example, if I have the absolute value of -8, well, -8 is here on the number line, and the distance to 0 is 1, 2, 3, 4, 5, 6, 7, 8 units away, and so that's why the absolute value of -8 is 8. If I do the absolute value of 5, well, here's 5 on the number line, and it's 1, 2, 3, 4, 5 units away from 0, and so that's why the absolute value of 5 is 5. And it's important to teach students that this is the definition of absolute value because the idea of calculating distances, regardless of which direction the distance is going, is one of the main applications of absolute value. And one of the things that I've seen a lot in high school is that students don't actually understand the definition of absolute value. And instead, they kind of just think about it as, oh, it's the thing that makes everything positive, which is technically true. Like the absolute value of a negative number will always be a positive number, and the absolute value of positive numbers are also positive. But the reason why that pattern is true is because the distance that you're measuring will always be a positive number of units, because distance is measured in positive numbers. So that's the idea of absolute value. And another topic that's related to the idea of zeros and absolute values is the idea of an additive inverse. So, the additive inverse of any number, so let's say the number is x, is written as negative x or the opposite of x. And it's the number that's equally far from zero on the number line, but in the opposite direction. So, for example, if I was looking at the opposite of 3, well, 3 is right here, and 3 is 1, 2, 3 units away from 0. So, if you go 3 units away from 0 in the opposite direction, that gives you the additive inverse of 3, which is negative 3. And the reason why it's called the additive inverse is because if you take a number and you add it to its additive inverse, it will always equal 0. So that's why it's called the additive inverse. And you can even have the additive inverse of a negative number. So, like if I have the number -9, well, that's 9 units away from 0 on the number line. And if I go 9 units in the opposite direction, 1, 2, 3, 4, 5, 6, 7, 8, 9 units away, then the opposite or the additive inverse of -9 is going to equal a +9. And this can get a little bit interesting if you also include the idea of absolute value, because if I look at the absolute value of -2, well, that's defined to be the number 2 because the distance from -2 to 0 is the number 2. So you would be finding the opposite of the number 2, which is going to equal -2 because if 2 defines the distance away from -2 from 0, and you go 2 units to 0 in the opposite direction, you would get to -2. So that's the idea of the additive inverse. And again, with any of these, if you take a number and you add it to its additive inverse, you'll always get the number 0 because 0 is like the boundary between the negative numbers and the positive numbers. So I hope you enjoyed this little video about the idea of 0 and absolute value, as well as the additive inverse concept. And if you have any questions, please let me know.